All right, welcome back, Algebra 1 students. This will be our last chapter of the year. So again, you can cheer silently right now, but this will be our last chapter of the year. And it's on basically on statistics, on measures of center and variation is our today. So mean, median, and mode. And these are things that you've probably heard of or seen before. Mean, again, if I asked you, what do you think about mean? Most of you would probably say average, and we'll talk about how we're going to calculate that in just a second. Median, that's the number in the middle. And then mode is the number which occurs most often. And so on the next page, it'll actually give the formal definitions, and we'll talk about how to actually calculate that in just a second. But mean is the average, median is the number in the middle, and mode is the number that occurs most often. So here we go. Mean, and the numerical data set is the sum of the data divided by the number of data values. So therefore, you're going to add them all up. Add all the numbers. Sorry about that. Let me try that again. Add all the numbers, and then divide by how many numbers there are. So you're going to add them all up and divide by how many there are. Now, the mathematical symbol for that is an X with a bar over the top of it, or X bar. Median. Now you're going to put the data in from highest to lowest or lowest to highest, and you're going to find the number in the middle. Now, if there's an odd number of numbers, that's great. Then you actually have a number in the middle. But if there's an even number of values, then you're actually going to find the average of the two middle values. So we'll get to that in just a little bit. And then mode. Mode is the mode is the number that occurs most often. Now, there can be one mode. If every number occurs only once, there actually is no mode. And if there's a tie, then there can actually be more than one mode. So again, if I take all the numbers and whichever one occurs the most, we would consider that to be the mode. And if there's a tie, there can be more than one. And if every single number only occurs one time, then you would actually consider themselves to be no mode. So here we go. Let's actually get some numbers here. The amusement park hires students for the summer. The students' hourly wages are shown in the table. Find the mean, median, and mode. So let's start with median. Or excuse me, let's start with mode. And I'm going to write these down here. Mean, median, and mode. Let's start with mode. Is there any number that occurs more than once? Well, 1650, 875, 865, 910, 825 occurs once. 825 occurs twice, and so that is the only number that occurs twice, and so therefore 825 is the mode. It's the number that occurred most often. Now let's do median, and notice I'm kind of working my way backwards. Median, I'm going to put the numbers from smallest to from smallest to largest. So 825 actually occurs twice. Then next would be 845. Next would be 865, 875, 910, 925, and 1650. So now they're in order. 1, 2, 3, 4, 5, 6, 7, 8 numbers. Now, so I have an even amount of numbers, so I'm looking at the numbers in the middle, and I want the average of the two numbers in the middle. So I take 865 plus 875 and divide it by 2. So the number in the middle of this particular question is 8, and my board's messing up here, 870. So the answer to the median is 870. Now for mean. Mean, we're going to actually add up all these numbers. We're going to take 1650 plus 875 plus 865 plus 910 plus 825 plus 845 plus 825 again plus 925. So we're going to add them all up, and that's 77.2. And then we're going to divide that by 8. That's how many numbers there are. And I'm going to get 965. So again, adding them all up and dividing by how many numbers there are. So there's the mean, the median, and the mode. Now, outliers. If I look back at the previous data set, you would notice that one person was making much more than everybody else. That is considered an outlier. If you have a number that is extremely high or extremely low, that is considered an outlier. Now, how does the outlier affect the mean, the median, and the mode? Well, it does not affect the mode at all. Ultimately, an outlier doesn't change the number that occurs most often because an outlier will only occur once. The median, it does, because you have an outlier or because you have one extra value, it does change the median by one spot. So if you have a very small number, then it would move the median down by one spot. If you have a very large number, it does move the median up by one spot. But the mean is what is affected the most, okay? The outlier is greatly affected by the mean, or excuse me, the outlier affects the mean the most because ultimately it changes the central number of the average because ultimately it adds much more to the data set. So describe one explanation for the previous outlier. Well, maybe that person was a manager. Maybe that person was been working there for a larger number of years than everybody else. Heck, maybe that person was the boss's son and he's just going to make more. So again, an outlier is a number that is much larger or smaller than the rest of the data set. So now, find the value of x. If the mean is 6, so 2 plus 8 plus 9 plus 7 plus 6 plus x divided by 6 equals 6. So again, adding up all the numbers and dividing by how many there are is how you find average or how you find mean. So now, solving this, I'm going to multiply both sides by 6 and get 36. 2 plus 8 plus 9 plus 7 plus 6 is 32. And so then using a little algebra skills here, I find the value of x to be 4. So in order to have an average of 6, the last value in the data set would need to be 4. Median. So now, they've already written it in order, and I want the median to be 14. So what would this number have to be in order for the median to be 14? 12 plus x divided by 2 would have to equal 14. This is how you would do it mathematically, and I'm going to also do it more logically here in just a second. So multiplying both sides by 2, x would have to be 16. So that was the mathematical behind it. Let's get more logical with it. If I told you that 14 was in the middle, and you are at 12, the other person would have to be at what in order for 14 to be the middle? And the answer to that question is 16. So now think about this last one here, and it's a starred question, so I would like you to pause and see if you can get it without me. And now I'm back. So again, 45 is one number, and the other number is x. How could I get a median of 51? Well, this number then would have to be 57. Okay, because again, that's the number to create 51 and being in the middle. Mathematically speaking, you're taking 45 plus x divided by 2, and that's equaling 41, or excuse me, 51. 102, subtract 45, and x would equal 57. Cooking shows the difference of the greatest number and the least number. In this case, we're talking about range. Range is the highest compared to the lowest. So the range is always you take the highest number minus the lowest number. So I have two shows here. We have show A and show B, reality cooking shows. Show A, the range for show A, the highest or oldest person in show A is 31 years old. The youngest person in show A is 19 years old. So the range of ages in show A is 12 years. Now, show B has a little bit of an outlier. Okay, there's somebody in there that's 48 years old. So that is the oldest person in show A, or show B, I'm sorry. And in show B, the youngest person is 19. So now the range in ages for show B is 29 years. This is considered a measure of variation. Measures of variation basically talks about the data set. Okay, the measure of center, which is what we did earlier with mean, median, and mode, basically talks about what is the middle or what is a number that represents the data. This one's representing the variation of the data. Okay, so the range of data. Now, another way to do variation is called standard deviation. Standard deviation is used a lot when talking about the normal curve. Okay, when you start talking about where does somebody lie compared to everybody else. So if you've ever been told that you're in the 50th percentile, or if you've ever been told that you're in the 90th percentile, they are using standard deviation and comparing you with normal, or with what's basically considered average. So now both range and standard deviation are measures of center. You will not need to memorize this, but that is the formula that we are going to use here in just a few seconds. Here's the steps. You're going to find the mean. You're going to then calculate the deviation. Then you're going to square the deviation. And then you're going to find the average of the squared deviation. Then you're going to take the square roots of that, and that is standard deviation. All right, so here we go. We are actually going to calculate this by hand. The first column is going to be all the numbers in the data set. So I'm just going to write down the numbers in the data set. So 20, 19, 25, 27, 30, 21, 29, 22, 27, 29, 20, and 31. Next, and this is going to take a few seconds, I apologize here, but now you want to find the average. So if you want to hit pause for a second and go ahead and try to find the average, you're going to add up all the numbers. So you're going to take all those numbers, add them up. So I apologize here. And divide by how many numbers there are. And so I get 25 as my average. So in this column, I am basically just going to put 25 all the way along. And some teachers will allow you to just write 25 at the top and then just draw an arrow down. But you're 25. The next column, you're going to take x minus the average. So now 20 minus 25. 19 minus 25. 25 minus 25, and so on. So you're going to do each one of these. Take the x, the number in the data set, minus the average. Now, next column, you're going to square the previous column. So now, because it's a negative number and you're squaring it, will always be positive. So negative 5 squared is a positive 25. So again, I'm going to take each number, and some of you may have to hit pause because I'm sure I'm going faster than you would. Okay, each number in the third column, and I'm going to square it. Now for the big finale. You are now going to take the last column in the data set, this one right here, and I want the average of that column. So add them all up. 25 plus 36 plus 4 plus 25 plus 16 plus 16 plus 9 plus 4 plus 16 plus 25 plus 36. So I add them all up. I get 212. Divided by the number of numbers there are. So I'm going to divide that by 12. 17.666. And then I'm going to take the square root of that. So square root of that number. So the standard deviation of this data set, rounded to the nearest hundredth, would be 4.20. What that means, when you interpret your results here, what you're talking about is from normal, how much does your data vary? Okay, so again, your data, every standard deviation in this particular case is 4.20. Now let's do the next one. Again, we're going to do the exact same thing. So I want all of you guys to hit pause. I want you to try this on your own. Sorry about the slight pause there. All right, so now we're going to find the standard deviation, and I did say to go ahead and hit pause if you want to, see if you can do this one on your own. But the first column is going to be writing down all the numbers in the data set. So take all the numbers in the data set and write it into the first column. Second, you're going to find the average. Now, I went ahead and found the average. It's 26. So again, you're going to have to go ahead and add up all the numbers and then divide by how many numbers there are. So I added them all up and divided by 12. Next column, I'm going to go ahead and change colors here. Now you're going to take the number minus the average. So again, you are going to get some positives. You're going to get some negatives here. So take the number minus the average. -7, 1, -4, -5, -2. Next, I'm going to square all the numbers. So the third column, squared. So again, because you're squaring something, it will always end up being positive. Sorry, it's not registering my pen here. There it goes. So now take the third column and square. I'm going to skip that one real quick here. So 22 squared. All right, so now for the big finale. This is we're off the chart now. Now we're going to take the last column. I'm going to put a big circle around it. I'm going to take the last column, and I want the average of the last column. Well, how do you find average? Well, you add it all up and divide by how many numbers there are. So I'm going to take each number in the last column. And again, you may want to hit pause for a second, but add them all up. And then divide by how many numbers there are. So when I added them all up, I got 670. Divided by 12 numbers, I got 55.833. And then I want the square root of that answer. So 7.47 is the standard deviation. Now, it's asking me to compare the two standard deviations. The first standard deviation, I believe for A, and I'm going to go back one slide, was 4.20, and the standard deviation for the second one is 7.47. What that means, the larger the standard deviation, the more the data is spread out. Okay, so your data set is more varied or spread when your standard deviation is larger. Explain to student missing a class today what the measure of center and measure of variations are. So the measure of center is basically the number that represents the data. I will tell you this. I always use mean unless there's an outlier, and then I would use median. The only time I would ever use mode is if the one number that occurs so much more than everything else, then I might consider using mode for my measure of center. Measure of variation talks about the largest compared to the smallest, or your variance of data. So range and standard deviation. Your homework assignment tonight is a worksheet. Do your best. Make sure you turn that into or talk to your teacher about any questions that you might have. Good luck and be safe.